chapter 6 from unit 3, that is Laplace Transform. Now from the name of the chapter also you're getting some idea, so there is some transformation. Okay, so let us see what is Laplace Transform. uh, these are the basic things which you are going to need, that is gamma function. You must know what is gamma function, then gamma of n plus n. Okay, these are all the values of gamma function. So we are going to need this in our chapter, so I have written it. So let us see the formulas. Now, in Laplace transform, what exactly you're going to do is, you will be given one function, okay, a function with a variable t, means f of t will be something like I can say t square plus 2t, whatever, it will be a function. Okay, now by applying the Laplace transform, we are going to change the variable from t to s. Okay, so in Laplace transform, what we are going to do, we are going to change the variable of t to s. We are transforming the variable t to s. So that is nothing but that is a transformation which we are going to use here. Okay, so let us see the formulas. So first, if f of t is 1, means if the value of f of t is 1, means your function is constant and its value is equals to 1. Okay, so f of t is 1, then L of f of t is 1 upon s. After applying the Laplace transform, you will get the answer 1 upon s. Then if your function is sine at, where a is any number, okay, like sine 3t, sine 2t, something like that. So after applying the Laplace transform, what you are going to get, a upon s square plus a square. So these are all the formulas. So what exactly you're doing? You're transforming the variable t to the variable s. That is the transformation which we are applying here with the help of Laplace transform. Okay. So I think so. Let us. Okay. There's one thing I would like to say. Yeah. Here you are having sine hat. So that is nothing but a hyperbolic function. Okay. Sine hat is what? Hyperbolic function. Cos hat is hyperbolic cosine function. Okay. Now see, if your function is t raised to n, so I have written here two formulas. Okay. Okay. So after applying the Laplace transform on t raised to n, you are having two formulas. So you will be confused which formula you have to use, this one or this one. So here I have written, if n is an integer, n is what? Integer, then apply this formula. Okay. Otherwise you are going to apply this formula. Okay. Means suppose you are having t square or t cube, then you can apply this formula. But if you are having t raised to 1 by 2, 3 by 2, fractional parts, so you have to use the first formula. Okay, so keep that in your mind. If your n is integer, then apply the second formula, otherwise use the first formula. Okay, so let us see the examples. So first one, find the Laplace transform of the following functions. First one is e raised to 3t. So just go and check the formulas. See, here you are having, if f of t is e raised to at, then what is the Laplace transform? 1 upon s minus a. Let us check. See, L of e raised to 3t. So that is 1 upon s minus. What is your a here? Your a is 3. Okay, your a is 3 because you are having formula e raised to at. Okay, so what is your a? Your a is 3. So answer is 1 upon s minus 3. That's it, nothing else. Okay, next your function is cos cube t. Now if you look at the formulas, okay, if you check the formulas, you are not having any formula related to cos cube, cos square. You are just having the formula of cos at, simply cos at. So what you have to do here is try to convert this cos cube t in cos at or in cos at form. Okay, so what I have done is I am using the formula of cos 3t. See, in cos 3t, what is the formula of cos 3t? It is 4 cos cube t minus 3 cos t. So from this I can get the value of cos cube t. Okay, so I am getting the value of cos cube t as 1 upon 4 cos 3t plus 3 cos t. Okay, now I am applying the Laplace. Okay, now 1 upon 4, this is a constant term. Now see, when you are applying the Laplace transform here, just simply open the bracket, L of this term plus L of this term. Okay, then when you are applying the Laplace transform, now this 1 upon 4 is constant, you can take it outside. Okay, then just you are having L of cos 3t, then again here you are having 3 by 4 constant, L of cos t. Now what is L of cos 80? It is s upon s square plus a square. See here we are having the formula. Okay, same formula I'll apply here. So your s is going to remain s only. S square plus a square. Now here a is 3. So s square plus 3 square. Here your a is 1. There is no a. Means there a is 1. So s square plus 1 square. So just I have simplified this. Okay. Now 1 upon 4 I have taken outside. So you are having s upon s square plus 9 plus 3s upon s square plus 1. Okay. So your s is also constant. S is also common in both the terms. You can take it outside. Then do the cross multiplication. Okay. See here I have done for cross multiplication 1 into s square plus 1 plus 3 into s square plus 9 upon this into this. Okay. So open the bracket, simplify the numerator. So finally you're getting this. So 4s square plus 28. So you can take 4 outside. So you'll have s square plus 7. So finally your answer is this. Okay. Understood. Just you have to apply the formula very properly. Okay. Okay, so next example, f of t is sine 2t cos t. Now here you will say you are having the formula of sine 80, you are having the formula of cos 80, but here there is multiplication. See, like in derivatives, when you are applying derivative for the multiplication terms, so what we are having one formula, right? So here also while applying the Laplace transform, we can't apply directly Laplace transform on the multiplication. Okay, so we need to simplify this also. So I am using the formula of 2 sine a cos. Okay, because you are having your function sine a into cos b. Okay, so I am applying the formula of 2 sine a cos b. Okay, so your a is 2t, your b is simply t. So finally you are getting half sine 3t plus sine t. Now apply the Laplace transform. Okay, open the brackets. Then half is constant, it will be outside. Then L of sine 3t. What is L of sine 80? It is a upon s square plus a square. For the first term, sine 3t, your a is 3. For the second term, it is simply sine t. So your a is 1. Okay. Again, do the cross multiplication. Simplify the terms. Okay. So you're getting this thing after simplifying. So 3s square plus s square is 4s square. And 3 plus 9 is 12. Okay. So again take 4 common. You will have s square plus 3. Okay, so this is the final answer. Understood? Okay, next there are properties of Laplace transform. So first property is exactly what we have used before. Like if there is a constant term, we take it outside. So we can see the first property. It is L of a f of t plus b f of t minus c h of t. So a, b, c are constant terms. So what can you write? A into L of f of t plus b into L of g of t minus c into L of h of t. Okay. So this is exactly what we have used before. Now the main important thing is first shifting theorem and second shifting theorem. You must know these things. Okay. So let us see what is first shifting theorem. If L of f of t is f of s, then if you are having something like this, okay, if you are having the question like e raised to minus 80 into f of t, means e raised to 80 is also there and another function is also there. So there you have to apply the first shifting theorem. So your answer will be simply f of s plus a. Okay,